Okay, today we're learning about the properties of natural logarithms. Okay, natural logarithms. Sometimes they like to, well, they abbreviate natural logarithms as LN. Okay, so what we're going to do is we're going to learn about the different properties, and then we are going to practice some questions that can come up on your test about natural logarithms. So the first basic thing is kind of the setup of it. What does it look like? So the setup of it is similar to logs. They are all related. It is y equals ln of x. I'm just going to do my cursives, or my l's as cursive so we know that they're l's. Now how this translates to exponential form is using the e. Remember using the e for the continuous compound. It is something that's used a lot with money and that sort of thing. So here's how it translates. So it goes e to the y equals x. Okay, so remember how we were talking about like the bases that could go right here? Now instead this ln simply means e. So instead of using a base because it was a log, we're going to use e because it was a natural log or an ln. It still can get translated into log, so a little bonus here is that if I kind of went from the exponential of e to the y equals x to logs, it would look like log base e of x equals y. So these are kind of the three different forms that you're going to need to know. So now we're going to look at some graphs. Okay, so I'm just going to go through all the graphs. The main thing you're going to need to know with graphs for your test is what the graphs actually look like. So these are kind of the main parts here when I say key characteristics and the graph itself. Pay close attention to this part as well. So this is a ln of x when a is greater than 0. So these are numbers 1, 2, 3, 4. This one, a ln of x when a is less than 0. So these are kind of your negatives. Your domain for both are all positive reals. So we are never going to have any negative x values, is kind of what that means. Our range is all reals. If we think back to our exponential unit, this is actually the complete opposite of the exponential graph. The exponential graph, the domain was all reals, and the range was just the positive reals. So here's how the graph looks. I'm going to do the best I can on this. So it looks something like that. It's not crossing the y-axis at all. It's only on the right side here. Okay, so some key characteristics of it is it starts very low. So it's going to start way down low. So it's going to start low. And then it hits at x equals 1. So see how it hits right here? There's a point right there. And then it just increases. Okay, then for your other graph, it's kind of the opposite. We're going to start up here. And then it's going to look like this. So again, opposite. It starts high. It hits at x equals 0 or x equals 1. And it decreases. Okay. Notice the differences between the graph. Again, a question might be gives you an equation and it gives you 4 different graphs, and you have to decide which graph goes with which equation. So you have to think about the key characteristics, whether it's increasing because this is positive or decreasing because your a is negative. So those are things you have to think about. So again, no other questions about that. So now we're going to go into purely the algebra form. Again, with logs, we really are just changing from form to form. So we're going to change from logarithmic form to exponential, and we're going to only use natural logs. So see how there's all these ln's and then the e's, because that means we're only dealing with natural logs. So remember, back to your previous page, ln of x equals y but e to the y equals x. So the different parts. So I'm just only going to do a part of these. We have x, whoops, I want to change color there. We have x in pink, we have x over here, so that's kind of your equals. Your y is what this one equals, but it's your power for your e. So I'll do the first three for you. First three. So right now we have ln of 1 equals 0. So 1 is my x, and y is going to be my 0. So I'm going to have e to the 0 equals my x, but in this case it's 1. And all I'm doing is changing forms. Nothing solving, nothing changing. So now I'm going to go the other way. So my 2 now is my blue, my y. And 7.39 is my x. So now I follow this form right here. ln of x, so my x 7.39 equals 2, because 2 is your y. I'll just do the first two. I think you guys can get that based on with the color coding. Okay, pay attention to each different part. So complete the rest of your table. Okay, so here's some more problems. Again, I think I'm going to do the first one for you, and then you're going to do the rest. So now, the directions, in case you read it, this is going to be without a calculator. Okay, these are things you can do in your head. So this is kind of a special one when we have ln and we have e together. They kind of cancel each other out. So if you type this actually in the calculator, it's going to give you a real answer. And guess what it's going to give you? The ln and the e go away, so it's just 8. Whenever it's ln e raised to a power, all that other stuff goes away, and it's just the regular old number. So you can complete the rest of this side of the table, these three right here. This is kind of a separate part. The next part is also kind of similar, kind of different. With these, what you do is, again, since we have the ln and we have the e, they're going to cancel each other out, but we're really going to have 5 times 2, because now we have that 5 out here. If it was just ln of 3, it would just be, or I'm sorry, ln of 2, it would just be 2, but now since we have the 5, technically it's 5 times 2, so it's 10 is your final answer. So really all you're doing is you're multiplying these two numbers together, as long as it's ln and e. So you can try those as well. Okay, this part is on the test. There's one question on the test like this, and it's making comparison, and I thought it was a really good question. And also it's going to be a good question that's probably going to be on the park. Okay, so the first, it says, look at the statement and the relational symbols. Relational symbols just means we have less than or equal to, greater than or equal to, and not equal to. So which relational symbol or symbols can replace the rectangle to make the statement true? For each, simply put A, B, C, or D. So we're going to put A, B, C, or D, whatever one it is. This is not multiple choice. You put the actual answer in there. So we have to simplify these first. These look like what we just did in the table. So ln e to the 8 is 8. 2 ln e to the 4 is 2 times 4. So guess what? It's also equal 8. So they are equal to. So I look through. Equal to is 3. What is the one that says 3 only? B. So it's going to be B. Okay? So try those other three by yourself. First do this part where you simplify what numbers it is. Compare the different numbers. And then look at your symbols. Decide whether A, B, C, or D goes with each of them. And I'll give you a hint. You are not going to be using A. So you're only going to be using B, C, and D. Alright, the next part is a property. So you have the property written, I'll just write the property right here. If we have n log of b of x, that is going to equal log b of x to the n. So I take that number on the outside and I'm going to raise it to a power on the inside. Now the same thing is going to work for ln. Now you might be thinking these look like the problems we just did, but they don't because there is no e in here. There's no ln e to the second. So this works by taking 5 and raising it to the power of 2. So the first thing I want to do is I want to use this property to change it from this form to this form. Okay, so to do that I do ln 2 to the 5th. Notice 2 to the 5th. 5 is a superscript. Okay, so what do now I have to think. What is 2 to the 5th? Oh, it's 32. So it's ln 32. So now you can try the rest of those. All right, the last part is actually solving some problems. So again, I'll do 1, you'll have to do 2, 3, and 4. So the first part is ln x. I can't simplify that anymore, but I can simplify 5 ln 2. So that'll become ln 2 to the 5th equals ln x. What is ln 2 to the 5th? ln 32, which equals ln of x. Now, my whole point is to just decide what x is. So when I have an ln and an equals an ln, those actually just go away. So my answer is just 32 equals x. So there's your answer. Okay, so try those rest of these problems, and then actually the bottom 3 questions are your closure. You're going to turn this whole paper in, and I'll give it right back to you after, or the next time I see you. And then remember, we're going to have a test at the end, or a March 5th if you are in 1A, and March 6th if you are in 1B. All right, thank you.